All right, going on to topic 4 now of Module 4, dividing radical expressions. And we will go over these objectives. So to start off, and we could shift that a little bit there this way, okay. We want to simplify by taking the roots of the numerator and denominator. Assume that all variables represent positive numbers. So our first thing, let's copy A, B, and C over there, and we'll work it out. Okay, so we're going to analyze this a little bit. And this actually becomes the third root. Now, 64 is actually 4 to the third power. And 343, you might have to do some figuring, is 7 to the third power. So if we take the third root of each of these, it just becomes 4 sevenths. Now for letter B, we're going to use that same technique we used before. We're going to divide these into perfect square factors, and we know 25 is a perfect square. Now for our x term, it will be x to the fourth with an x left over. And for our denominator, this is a perfect square. So as you work this out, over here, this is going just to become 5 x squared. And this is going to be over 2y. And this is just going to be the square root of x, because it's over 1. Here, the same thing. We're going to divide these into 2 parts. And what I'm doing is to show you a strategy. This is going to be a to the fifth. And then what's left over is a to the fourth. And this will be b to the 15th. Actually is a multiples of 5. So that's a perfect fifth there. And then it will be c to the 15th. And then over here we just have a c left. So this will become then an a. Our denominator will be b to the third, c to the third, and this will be the fifth root of a to the fourth over c. So not too bad. This one was a little tricky in that you had to kind of figure that one out. And let's go on. Now when we copy these down, you can put them all under a common radical sign instead of writing them separately like this. Now what we're going to do is simplify. Well, 5 goes into there 24 times. So we have the square root of 24. Now from a previous section, we said that was the square root of 4 times the square root of 6. And the square root of 4 is 2. The square root of 6 is the answer for that one. Now for this one, 5 goes into there once, 5 goes into there, 125. So we now have 4/5 the cube root of 125. The cube root of 125 is 5. So we have 4/5 now times 5. The 5's will cancel out, and that leaves you with an answer of 4. Now here the 3 will go into there once. 3 will go into there 7 times. X to the second goes into there. This becomes a 5. This cancels out, and this will become a 9. And this cancels out. So we now have the 4th root of 7 x to the 5th y to the 9th. And we're asked to simplify. Well, the same rules that we used before. 2 radical signs. And we're going to separate them into those that are perfect fourths and then whatever's left over. Well, 7 doesn't go into anything here, so just a 7. Here we're going to have x to the 4th. That's a perfect fourth, and there's an x left over. We have y to the 8th, and there's a y left over. So this becomes x, y to the 2nd, and the 4th root of 7xy. Again, we're looking at strategy. Can write these all under a common radical sign, do the simplification, and continue with it until you end up with a basic simplified form. Now in example 2, they want you to rationalize each denominator. So as you copy these down, copy them in this form, separate them like so. Because the square root of 8 is irrational, we want to make it rational. And we don't want the numbers to be too big either. And we want to simplify. So let's take a look at it. Now the top is the square root of 5. But 8 is actually 2 the square root of 2. That is the square root of 4 times the square root of 2. So when we take out the square root of 4, we get this. So to rationalize our denominator, we have to then pick a number or a radical that will make this rational. And I think I can change colors again. It will be the square root of 2. But if you do the bottom, you must do the top. Remember, the square root of 2 over the square root of 2 is a 1. We are allowed to multiply anything by 1. So this then becomes the square root of 10. And this will become the square root of 4, which is 2. 2 times 2 is 4. So there's our answer for A in part 2. Now there's another way to do that as well, but that's a good little technique there. So we said already that the 8 was 2 the square root of 2 over the square root of 7a. So what will we multiply 7a by to make it rational? And the answer is the square root of 7a. But if we do the bottom, we have to do the top. So our top will become 2 the square root of 14a. and our bottom just becomes 7a. So it's 49a squared, which is that. So anytime you have two radicals that are the same to the second power here, it just becomes that. Okay, now for this one, here we're dealing with third root. So the top, I think, stays the same. The third root of x squared. But the bottom, to help us out a little bit, that's going to be the third root of 5 times 5y. Now I separated the 25 to let you know that you just need another 5 there. So the bottom will be the cube root of another 5. That will give you 5 to the third, which is 125, a perfect cube. And we have y to the first, so we have to multiply this by y to the second. And what we do to the bottom, we have to do to the top. Remember, this is a 1 here. These are all 1s. So our top now becomes the third root of 5 x squared y squared all over 5y. This will be 125. The third root of 125 is 5. Y to the third is y. Okay, hopefully this is a strategy now as you look at these. Let's go on to our last example. Here they want us to rationalize the numerator. So let's copy these down. Now I could recall when I did these on MathLab. One time I was on a roll and I just rationalized the denominator. But here they're asking us to do the numerator. So let's look at what 12 is. What is 12? 12 is 4 times 3. Square root of 4 is 2, the square root of 3, over the square root of 5. So now to rationalize this, all I need to do is multiply this by the square root of 3, and the same in the bottom. So this becomes square root of 9, which is 3. 2 times 3 is 6 over the square root of 15. Now for this one, we're looking for a cube root. So we have to multiply this by the cube root of 3 times 3. We need 3 3's, so this will be 9a squared. And our bottom, now notice what I did. I teased that bottom apart into 2 times 3. Because, again, our 9 is 3 times 3, and then we need an a squared there. But I don't know if you noticed, we now have 3 3's. That will come out as a 3, but we'll do that in a moment. Let's rationalize our numerator here. So 3 times 9 is 27. Cube root of 27 is 3. And then a times a to the second, a to the third. The cube root of a to the third is a. So our numerator is rationalized. But now, what do we have left in the bottom? Well, we're going to take out this 27 here. Cube root of that 27 is 3. And then we're left with a radical, the 2, and the a squared. So again, this is a little tricky. I left the 9 up there because 3 times 9 is 27. Now, this was a 6. If we multiply 6 times 9, that's 54. If you take out a 2 out of 54, you get 27. So that's a perfect cube. That's the 3 that we've taken out here. So left under the radical, we have a 2, a squared. But now, what do we do here? Well, these are common factors. So we can factor out the 3. So our final answer here is a over the cube root of 2a squared. I need to put my, looks like I forgot my b down there too. That's much better. So we need to have our b squared in there as well. So the 3's would cancel out, and we have a radical in the denominator, but we have rationalized our numerator. Okay, let's wrap this up.